This video will be long, and I know it. Because I've got a lot of electric shit. Excuse my language. And I'm gonna show it to you. Fuzziness. Stop being dirty, for frick's sake. Finally! Okay. Well, I've never done this yet, but we're gonna do it now. I'm gonna show you all my electronic crap. I've shown you, I have many videos of my electronic stuff, about my relays, my cooling fans, power supplies, LEDs, crap like that. And, however, I've never done one video about it all. But I'm gonna do that now. Luckily, this thing can pause the video without editing. So much more convenient than that freaking iPhone. What was I gonna do again? Oh, yes. So, in my high quality videos, my 720p ones, this is what I record those with. It's an iPhone 6. It's okay. It's an okay one, but the screen doesn't work well anymore. It does ghost touches a lot, and it often does the opposite of ghost touches. What are ghost touches? Ghost touches are when, like, the phone thinks that you're touching the screen where you're not. So, like, you'll look at your phone and it'll like click a button or something. Or something like that, and it'll move around and when you're not even touching it at all. Or, the opposite of ghost touching is like where you touch stuff and it doesn't react at all. It doesn't think you're touching it. Oh, and ghost touches are also like when you tap a part of the screen when you put your finger on it and it thinks you're touching a different part. Like you click a button down here, but the phone clicks a button up here. Yeah, this does that a lot. It's got quite a screen problem. But yeah, but it records nice videos, and it cannot pause the video, which sucks. This is what I use to hold the phone for the videos. It's a really crappy, shaky, holder. It's basically made out of a bendy spring. That's why it's so shaky. Yeah, it's meant to grab onto a table or something. And yeah. I've recorded a couple of very little short videos with this, my Chromebook. It's not actually my Chromebook, it's the school's. This is the school Chromebook. Well, a school Chromebook. They gave these to the, if your school doesn't do this, then I'll tell you why I have this. Here in Nova Scotia, I know some other countries and places do it too, but here in Nova Scotia, Canada, we, ever since COVID spread it everywhere, the school has been giving the students their Chromebooks to take home with them, just in case they don't have, a computer at home that can do online learning. They give us these so that we can do online learning if COVID goes crazy and everyone gets infected or something and school's gotta shut down. They can switch to online learning, and if somebody doesn't have a usable computer, they give us these just in case. I don't have internet at home, so whether I have this or not, I'm not able to do online learning. I have the Windows XP computer in there. Probably can't do online learning. However, my dad has a HP Elite desk over there, right there, right next to my PS3. That does work. He hasn't used it in a couple of years though. No clue why. So, if we had an internet, I could do online learning, but I don't have internet, so I can't do online learning. So if COVID goes crazy, my school is fricked. But oh well. I usually use that to record if I'm at school and need to record a video to tell you something. There we go, that's a bit more centered. My PS3 is almost always on in the background of my videos. And I'm almost always playing Minecraft, mainly. I used to play GTA a lot, different versions of GTA, mainly GTA 4 and 5. I used to have San Andreas, but that disc stopped working, got too scratched. And when I record my... my freaking, could you stop being dirty? There we go. And when I record my, Minecraft videos up here, I use this really tall tripod that can hold my phone. That's why I only record my Minecraft videos with my phone, is because my phone's the only thing that fits in that tripod. This is too big. These freaking companies that make these phone holders and phone tripods and stuff, they don't care about tablets, and I don't get it. They make it big enough to hold any size phone, but just a little bit too small, and it can't hold a 7-inch tablet like this. It sucks. Oh, there it is. This. Oh. Right. I haven't exactly gotten the hang of this thing yet. There we go. So, that extends up about that high. Or, you can untwist these. And extend it up way freaking more. That's nearly touching the ceiling. I'm a really short guy, and I can barely freaking reach this. I'm gonna try to get the phone up there. And there we go. Rotate, for frick's sake. Okay, whatever. I'll rotate the whole thing. There we go. And yeah, that goes up higher than my TV. So, I can just adjust it to the right, height, and it can record my TV perfectly. What you saw in the background there was our Christmas tree. Yes, it's that small, because we don't have room for an actual one. How have we hit 10 minutes all freaking ready? Jeez. Ow. Frick. Alright, there we go. So yeah, that's how I do my recording. But now let's actually get on to the electronics. Small components box. So this thing has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 slots in it. This one here is 1, but it's the size of 4. It's full of capacitors. This has been in a whole whack. Almost all of my electronic videos have the components box in it. Well, the small components box. I'm gonna try to hook up an angle where you can see what's going on here. Alright, there we go. That's somewhat okay-ish. A little. So, this components box is broken. It's been broken since I got the thing. My dad gave it to me. And, yeah, these 2 hinges are broken. This one's still good. And, yeah, so all this bottom row is LEDs. Well, not just LEDs, but lights. And here, I've got this is the miscellaneous. Reds, yellows, and oranges. Greens, blues, and whites. So in the miscellaneous here, I've got this, which is a bicolor LED. It's red and green. And the green terminal is broken, so the green one only works if you kind of squeeze the light. This is not an LED, it's a neon indicator light. So like in that phone that I took apart, this is one of them little tiny fluorescent ones. This is exactly the same type of bulb. It's just a little smaller. Yeah, these are filled with neon gas, and they light up a nice orange. These are common in high power things. There's one of them inside of the extension cord right there. There's one of them inside this hot plate. There's one of them in this old microwave. There's one in this power bar switch that doesn't work. Same thing with this power bar. The light is down there, and it's also burnt out. This is the power bar that I plug my power supplies and stuff into when I record videos in this area. And yeah, those are some little tiny neon fluorescent bulbs. Yes, those are fluorescent. They're the same types of lights as these big ones here. Them big white ones. But they're teeny tiny. And they have neon gas in them instead of mercury gas like those ones. So instead of brighting up white, they bright up orange. Well, those don't bright up white, but they actually light up ultraviolet. But they've got a layer of phosphor coating, that's called, that turns it into white. Phosphor coating is this stuff that basically just changes the wavelengths of light. One wavelength goes in and different wavelengths come out. This has no phosphor coating, so you can see right through it. And that phosphor coating turns ultraviolet into white. Oh, well, ultraviolet into red, green, and blue. And when red, green, and blue shine together, it creates white. Now, I brought my plasma balls over here because of that little neon lamp. This is my low power one. And my high power one. It's so cool how they react to each other like that. But yeah, if you notice, when I put this close, it lights up. Hold on, I'm gonna turn the light off. Oh, and there's a switch over here behind the bed here. It's just on a wire, and click, and it turns on and off the lights. Where'd that neon bulb go? There it is. See? That just makes that nice smell of ozone. This little one here, the bulb is removable. I made a video about these, where I explain how they work and stuff. There comes the bulb. Now it's just a little Tesla coil. Now it's just a little Tesla coil. That's it. No plasma ball, just a little Tesla coil. If I touch the wires onto this, as you can see, it gets bright. It lights up very bright. And yeah. That does that to normal fluorescent bulbs like those as well. Here, I'll show you. Huh, maybe not those ones. But my high power one. I'm really surprised those aren't lighting up. Huh. Well, I do have a light that does work. Why did my video just end on me? That was weird. Alright, I got a light that I know works. That I know works with these, because I've done it many times before. It lights up very bright. Very nice and freaking bright. This light here doesn't actually work. It's burnt out. One of the filaments in there is broken. But that doesn't stop the plasma ball from lighting it up. Works this one too. I wonder what would happen if... Aw. It's boring. Thought it would light it up pretty good, but nope. Oh, we'll once again remove the bulb of this one. Just push on one side, flip it, push it on the other side, flip it, push it on one side, flip it. Push, flip, push, flip, push, flip, push, flip, pop. And there we go. Makes it very bright. Holy crap. It's so cool. Now, when I do that, as you can see, it arcs. And those arcs frick up the radio. I'm gonna turn... never mind. I was thinking I would turn up the radio and then spark this and show you, but if I turn on the radio, I'm gonna get copyright striked. Frick you, YouTube! And yeah, so that's the fluorescent bulb. And those are my plasma balls. Well, fluorescent, like the neon one. Little neon. Throw that back in there. There we go. Alright, I'm gonna go grab my LED powerer. Alright, I got the LED powerer. I put this all together myself. I designed it specifically to power LEDs. So it's a 4 battery, so 6 volts, battery pack. And, however, I wired it up, and after I wired it up, it can only hold 3 now. But, oh well, it's okay, it only needs to hold 2. Because if you go more than 2, it blows LEDs up. LEDs are 3 volts, and this makes 3 volts. So yeah, because these are 1.5 volts each. You hook them up in series, the volts add together, 1.5 plus 1.5 equals 3. So yeah. So with this bicolor LED, the little yellow wire I've got coming off of it is the negative. With this LED power, it's got your on-off switch. So you click it down, and it turns on. Click it again, it comes up, turns off. And 2 volts mode and 3 volts mode switch. 2 volts, 3 volts, 2 volts, 3 volts. And your output plugs. So this one has 12 LED slots. The top ones are positive, the bottom ones are negative. So you take an LED, switch it to its voltage mode. There's a 3 volt LED, so it's on 3 volts. And turn it on, and there we go. And there's that big capacitor in there, 4700 microfarads. So it fades away when you turn it off. Slowly fades to dark. However, if you just want to turn it off instantly, you click this button here. Boop. And it completely turns it off. Just like that. This is a super bright red LED. This is a diffused bicolor LED. The difference between a super bright and a diffused is super brights are meant to be they're supposed to act like a flashlight. So they get out of there. There we go, frack. So they don't shine around everywhere. They shine it like a flashlight. So it's right dim everywhere. But I shine it right at the camera and it's right bright. I mean, if I shine it at something, it makes that circle where it's really bright. Again, just like a flashlight. These are super bright LEDs. Diffused LEDs like this one, it's foggy. Hold on, I'm gonna grab that super bright again. As you can see, it's clear. This one is foggy, it's cloudy. What does the cloudiness do? And what does it mean by diffused? The cloudiness makes it so it's it reflects it out kinda everywhere, nearly evenly. It is definitely brighter at the top, but now you can clearly see it quite a bit everywhere. It appears nice and bright everywhere. That diffused means it reflects it around kind of everywhere even. Now, with the bicolor LED. I'm going to stick that yellow wire into the negative. This is diffused, this LED. Stick that in there. Come on. There we go. There's a screen. I'm really surprised that actually managed to turn on without me squeezing it. And there's red. This red looks pretty orange on this, and it's very dim. Neon. This one here, this one is also not an LED, it's a incandescent. And this does not have loose wires coming off of it, so I'm not able to hook this one up on this. Well, I might. Hold on. No, never mind, I can't. I've got another incandescent here. This one's only 2mm, it's very tiny. I've got it hooked up to these wires, because its terminals are very tiny, and they will break very easily if they bend. This is not a 3-volt light, it's a 9-volt light, so this makes it very dim. But it does light up. As you can see, it's lighting up. Very dim and very orangey. Nice incandescent color. And this is a red LED. Why do I have it in the miscellaneous? It's 2 volts. There is no way at all to tell the difference between a 3-volt and a 2-volt LED. There's no indication at all. The only way to find out if it's a 2-volt is if you almost blow it up, giving it 3 volts. If you get an LED, have your powering thing off, have it on. I don't know why I'm telling you this, you don't have one of these, but when I test an LED, I always set it to 2-volt mode, then I hook it up, and I turn it on, and I switch it to 3 volts and then 2 volts really quickly, so like, just like that, chick. Why do I do that? Because when I switch it to 3 volts, for that really quick little moment, if that thing gets brighter, and then darker, like, it goes brighter, darker, then I'll try it again, but slower. If I click, Click. It stays on nice and bright. 3 volts. But if I do the really quick one, but when I switch to 3 volts, it gets real dark. When I switch to 2 volts, it comes back on. It's 2 volts. Because that was a I very near killed it there. When I give it 3 volts and it turns dark. That's a very close to killing it. So you gotta be careful. But yeah, that's how I test the voltage of an LED. This piece of crap has a wire, and it makes it really annoying. There we go. Oh, you can't see it. There we go. Yeah. So, components box. In here, we've got a whole bunch of warm white LEDs, but they've got resistors on them. 240 ohm resistors. So, you can plug them into 6 volts and they'll work good, without blowing up. 6 volt LEDs. Oh, by the way, why do I have a miscellaneous section? The LEDs that go into the miscellaneous section either aren't LEDs, or are a different voltage than 3 volts, or are 2 colors or more. If they have more than 1 color, and or they're not 3 volts, and or they're not an LED, they go in the miscellaneous. But if they're a 3 volt single color LED, they get sorted by color. This is another bicolor LED. It's smaller and it's brighter than that one there. 3 volts. Yes, very bright. And and it's diffused. This one, green's a lot brighter than red. This one, red's a lot brighter than green. So here's green. Lip. Here's red. Very much brighter. And the last LED in my components box, I'm going to throw all these little ones back in here. It's this one. It's an RGB color changing light. You plug it in and it slowly fades through different colors. This one, you cannot tell the polarity by looking at it, because both of the things in there look the same. And yeah. Changes through a whole bunch of different colors. And since it's more than 1 color, it's in the miscellaneous. Now, the reds section. Most of my reds are diffused. I've only got 4 of them in here that are not diffused. So, I've got 6 of these, old 90s rectangular, 5x2x7 millimeter red diffused LEDs. Yes, that's their measurements. 5 millimeters wide, 2 millimeters thick, and 7 millimeters tall. I got this one out of the phone I took apart in the last video. Very, very dim. Oh, by the way, there's this really long wire here with only 2 LED slots on it, just in case I want to, like, put that into a small area or something, put it into a device, or I can shine it around kind of like a flashlight, but without having to move this thing. Here's my other 90s red. It's a little bit bigger. It's 5 by 2 millimeters, just like those other ones, but it's 8 millimeters tall. Those ones are only 7 millimeters tall. This one's 8. It's got quite a nicer red. Now, a diffused red, this one's very dim. There we go. Very dim diffused red. 5 millimeter red. Now, 2 millimeter red. Once again diffused. Quite bright. Get the frick over here. Use the same bulb. Yeah, they're the same bulb. This is being real difficult. I'm just gonna yank these all out. There we go. It'll be much easier to go through them now. That is the same. That is the same. And that is the same. All the little LEDs there are all the same. 2 millimeter diffused red. These ones are also 2 millimeter diffused reds, but their plastic is quite darker. I'm gonna throw one of these other ones in here for comparison. Man, that one's really dark. I did not know that that one was as dark as it is. It looks exactly the same as these others, but it's right super dark. Dim. There's a bright one. And the other one, it's just the same. And all those antique ones, and those diffused reds, the super bright red. And these are not actually red, but these emit a wavelength of light that we cannot see. Our eyes don't have the crap in them that processes this wavelength. So these make light that only cameras can see. I can't see this thing, man. I cannot see that light coming off there. That purple, that's completely invisible to me. That wavelength is called infrared, because it's before red. So on the visible spectrum, it goes from red to orange to yellow to lime green to cyan and to blue, and then to a dark purple, and then to ultraviolet. Magenta does not actually exist on the spectrum. Interesting fact there. Magenta should be after violet, but after violet is ultraviolet. Ultraviolet definitely isn't magenta. Magenta is not a wavelength. Magenta is a dichromatic color. It does not have a monochromatic version. You can have dichromatic yellow and monochromatic yellow, but you can only have dichromatic magenta you cannot have monochromatic magenta. Magenta is the only secondary color that cannot have a monochromatic version. You probably don't understand what that means, but oh well. There's this YouTuber called Technology Connections, and he's got a video called The Weird World in RGB. Watch that, he'll teach you a whole lot about light. Light physics are one of my biggest interests. Light physics and electricity, my two biggest interests. And yeah, so that video is awesome to me. And yeah, that's my LED power, and those are all my reds. Now, in my yellows and oranges slot, I only have 2, or 4, I mean. Well, technically 3 LEDs in here. This one is amber. So it's between yellow and orange. It's too yellowy to be orange, but too orangey to be yellow. It's amber. That's what this color is called. My camera sees that as pretty orangey, but to me that's definitely amber. Amber is definitely my favorite color. And we've got 2 little 2mm diffused orange ones. Oh, and that amber is a super bright. This is also amber, but it's a little tiny circuit board with 2 tiny little LEDs in it. And yeah, that's the yellows and oranges. And the greens have quite a bit in them. Well, not as much as the reds, but definitely more than the yellows and oranges. So, a bunch of my greens are these little tiny ones. These are 2mm, but they're right short as well. And the problem? The terminals are as well. They barely fit in the frickin' power. But I can get them to work. These lit up the buttons on a stereo I took apart. A stereo, like one of those big cube boombox thingies with the cassette player on the bottom, CD player at the top, and the screen and all that. It's one of them. And I've got an antique 90s, 1991 to be exact, 5 by 2 by 8mm. All these greens aren't true green. They're very limey. That's a diffused. These little teeny tiny ones aren't diffused. They're not very bright though. So I wouldn't call them... They're not diffused, but I would not call them super bright either. Because they're not bright. Diffused 2mm. Another one of those. And a couple more of those right teeny tiny ones. And a super bright. And another super bright. In the blues section, it only has one type of LED in it, and only 3 of them. They're completely identical, and there's only 3. They're very bright. These are super bright LEDs. However, I would actually call them super bright LEDs. They are bright. Blue ones in general seem to be real bright. There's something about blue LEDs. They're just brighter. Why the actual frick? is that not turning on? That's weird. What about this one? Yeah, this one's turning on. Yeah, as you can see, it is very bright. These are bright. I can't remember what these were out of. I used to have 4 of them. I blew up one of them as an experiment. And in the white section, I only have 2 types of LEDs, but I've got a whole bunch of one kind, and only one of the other kind. So these are all warm white, except for the one that's different. These are all the same LED. These have a reverse lens. The lens goes like into them instead of coming out. So they've got a little pit in the top of them. So what does that do? It diffuses it. This looks like a super bright because it's perfectly clear. But that weird shaped lens diffuses it and it makes it shine out everywhere. Everywhere evenly. It's a very good diffusing system. Works very well. Yeah, it's a nice incandescent warm white. And the only one that's different is this one. This one is a super bright, an actual super bright, not diffused. 2mm cool white. It's very bluish of a white. Cool white, that's called. I used to have a lot more of these warm whites, but I blew up a lot of them in experiments. Because I had so frickin' many of them, I did not care how many I blew up. And yeah, that's the LEDs. Well, there's this circuit board here, which has 4 of them on it. 2 orange ones and 2 green ones. They're hooked up in series. This is a 12-volt strip. I plug it into my power supplies, my bigger power supplies. I'll do that in a bit here. And the other sections of the components box, the small components box, I keep this incandescent in the capacitors section because of its wires. And yeah, the capacitors section. These are full of either 6.3 or 10 volt capacitors. And they're 1000 microfarads or more. This one right here is 2200 microfarads. Some of these are 1000, some of these are 1500 like this one. Some of them are 2200, some of them are 3300. And I use the only 4700 one in this. And in the resistor section, we have a microphone. Microphones are a type of resistor. Change resistance with sound waves. We've got a variable resistor. Well, I've got a few variable resistors here. Variable. 330 ohm. 200 ohm. And this is hold on, I gotta calculate this. Brown, black, brown, 100. Wait, yeah, brown, black, brown. Brown, black, brown, gold. 101. 10.1 ohms. If I calculated correctly. Seems pretty specific. This is 100 ohms. And this is a photoresist. Oh, no, it's not a photoresistor. Maybe it's a photodiode. But yeah, that senses light and changes resistance. And 330 ohm. No, 100 ohm. And yeah, that's the resistors. And in here is just a bunch of pieces of metal. We got a sheet of very thin aluminum. Aluminum. And a whole bunch of just pieces of solid wire. And just some other little tiny pieces of aluminum. And up here is switches. Toggle switches, to be exact. They could be on and off, well, one way or the other. So this is a two-way switch, but it doesn't act like a slide switch, it acts like a button. Click it once, it goes in, click it again, it goes out. Very similar to this button here. However, all the others are slide switches like this. Like the 2-volt, 3-volt switch on this. Oh, and that is a 100 ohm resistor. A lot of my switches in here, like this one, have 3 positions. And yeah, it's a changeover switch like the others. It's like one output or the other output, and off. I like these because they're off position. And yeah, and in here is a batteries section. So I've got a little rechargeable lithium polymer 3.7 volt here. And I'm going to put some 3-volt ones in there too to power LEDs. Right here, I've just got a couple of little motors, little tiny motors, 4 of them. They're exactly the same. I took these out of a drone. Frickin' magnets inside of these motors, connect them with all the LEDs. And up here is diodes and transistors. So, we've got some high voltage rectifier diodes. This one is real sick. And we've got a diode bridge. A triac, I think this is no, this is a transistor. And this is also a transistor. This is a 2N2222 transistor. I'm going to be using this to make a Tesla coil real soon. I used to have a triac in here. I think that's what it's called, a triac. Acts almost as if it's a relay. And we've got some low voltage rectifier diodes, little ones. I'm gonna go see if I can find that triac. I found the triac. And right here is buttons. So these are very similar to the switches, except they don't stay in the position you sit. They automatically spring back. This is the one I took out of that phone, the quadruple two-way switch. And we've got some normal push buttons that we got out of the phone as well. Got this really weird switch button thing. I have no clue how it works. And everything else are just normal old buttons. These ones. And in here is miscellaneous other stuff. So we've got an electromagnet and a bunch of buzzers, little ones, 4 of them. And a whole bunch of fuses that I've taken out of stuff. Man, I've got more of those things than I remembered. And these little buzzers, they're just like a little speaker. Treble-y speaker. They're not exactly meant for playing audio. They're meant just to be given a square wave input, and they'll be... And yeah, these are fuses. Little fuses. This one... 1.5 amps, 125 volts. This one... 1 amp. It just says 1 amp. It doesn't say voltage. .3 amps, 250 volts. This little tiny one. I can't read the amps, but 250 volts. One amp, 250 volts. And this last one, 15 amps, 125 volts. No, 250 volts. 15 amps, 250 volts. Wow, this one can be used for the house. That's a high power fuse. And there we go. There's the small components box. And the LED power. And my Tesla coils, aka plasma balls. I'm definitely making one of these soon. It won't have one of the, gas bulbs in it, like these ones do. But it will have a little wire coming out with a few thousand volts coming out of it. They're very simple. Tesla coils, they're so freaking simple. I did not know how simple they were until very recently. They require a 2N2222 transistor, which I have in there, and a 22 kilo ohm resistor, which I can easily find on some circuit boards outside. And there's the schematic for a Tesla coil. As you can see, it's very simple. 22 kilo ohm resistor, 2222A transistor, and an LED, that's optional, and 3 windings inductor, and a 275 windings inductor, and that's it. Oh, and a 9-volt battery. And a switch. And yeah, it's very simple. I've got everything I need except for the 22 kilo ohm resistor and the 275 coils inductor. Well, windings inductor, 275 windings. I can easily make that. I can just wrap around some wire around a piece of iron 275 times. And there's got to be at least one device I've got that I've taken apart that has a 22K resistor in it. Pause. Man, there is a good 30 pounds right here. This is my big components box. So in the little top covering here, I've just got some parts that I've put aside because of something I want to make. I've got this transformer. This is a 20 to 1 step down. So this changes 120 volts to 6 volts. And it's split phase. So I can either have it 3 volts, or 3 volts, or 6 volts. So this could be used to power LEDs as well. I switch it to 3 volt mode. This is going to be the only power supply I've got that you can switch voltage. And I've got rectifier capacitor. No, there is no real such thing as a rectifier capacitor. That's just a capacitor I'm going to be using for the rectifier. So I'm going to call it the rectifier capacitor. Voltage switch. This is a 3-way switch. Yes, an actual 3-way switch. I'm not making a mistake this time. These are 2-way switches. This is a 3-way switch. So it's got the input, the black one, and you can choose the output. 3 outputs instead of just 2. Oh, and off. So this will be the power, AC and DC, and polarity switch all at the same time. So it'll be off, AC, DC polarity 1, DC polarity 2. That gets rid of so many switches. It uses up the place of so many switches. I get to save a lot of switches just because of that thing. And this is going to be a flasher switch where you can turn it on and off really rapidly. And yeah, those are just some parts that I've thrown aside for that. Now in here, get out of the way switch, got a couple of cooling fans. There's 12 volt cooling fans. That's one of them. Here's the other one. Sadly, that CPU one I had stopped working. And this one has a broken blade, but it still goes, it's just a little shaky. A big buzzer that I got out of that phone, it's too big to fit in the small components box, so it's in the big one instead. Some speakers. Holy crap, I really gotta solder those. I got these out of a speaker system, a stereo desktop speaker system. I got this out of those headphones I took apart. I got this one and another one. Don't know where it is, but I've got this one and another one identical to it out of a boombox, CD player radio boombox. Transformer. Not sure what voltage this makes, and it's got its own little rectifier hooked onto it. Ouch, that's a little sharp. And we've got a rectifier, another 3-way switch, a big thing of solid core wire, a big power switch. This is probably the weirdest capacitor you'll ever see in your life. This is 14 microfarads. 14! Only 14. However, it's very high voltage, 300 volts. And it's not, the reason it holds so little capacity is because it's not an electrolytic capacitor. These are electrolytic capacitors because they have electrolyte in them. These do not have electrolyte in them, so they hold much less capacity, but they're much higher voltage. Exact same thing with this one. This is the same thing, it's only 3 microfarads. And this one is 8 microfarads. And I've got another 3 microfarad one in there somewhere. Oh look, another speaker that I got out of the headphones. This is a thermostat. It turns on like a switch when you give it enough heat, when it gets to a certain, when it gets hot enough. Little motor, basic DC motor, 9 volts. These are the things that make the box so heavy. I've got this multi-voltage transformer here. So we've got our inputs. This one isn't used. I don't know why it's there. But yeah, we've got our inputs, our 120 volt inputs, and a whole whack of different outputs that give us a bunch of different output voltages. It's heavy. This one is even heavier. This is a good 10 pounds. This one is the same thing. It's a multi-voltage transformer. Oh my god. These are the inputs. I have no clue what this one does. It is used, because it's got a wire hook to it, but don't know what it's for. And we've got less combinations of output voltages. Why are these transformers so big? Because they were out of stereos. All them little tiny green LEDs I showed you, the little teeny tiny ones that I got out of a stereo. I also got this transformer out of that same stereo. I got this transformer out of a different stereo. It was the same type of stereo. Exact same type, different company. Sighted transformer means power. This one's a smaller transformer, so that one I took apart actually gave out less watts out speakers. This one, the stereo that this one came out of, could deliver more power. It was a better one. These are what take up a lot of the weight in this box. Not all of the weight, but a lot of it. As you can see when I do this, I'm just using my arms right now. It shakes the whole bed. My heaviest components. Why the actual frick is there a Nerf dart in here? Weirdness. Another thermostat. And another thermostat. This one's different. It's adjustable. You can adjust to which temperature it turns on. I got these little ones out of a heater, and I got this one out of a fan system. Inductor. I don't know why I took this out of something. I took this out of a computer power supply. I'm pretty sure I did that just because it looks so cool. Just check that out. The neat red and green wires. It just looks so cool. It's a really neat looking component. Polarity switch. This changes the polarity. You put your input DC in here, and it switches the polarity out of these wires here. And I've got it encased in some cardboard, so the wires can't break, and so you can glue it to stuff easier. I'm definitely putting that into my next you know that little rectifier board thingy that I made that you can attach to different adapters? I'm gonna put this onto that. I've got some higher voltage capacitors. 1000 microfarads, 25 volts. And some, a little bit larger capacitors. This is 10,000 microfarads, 75 volts. This is definitely out of an amplifier. A couple of more motors. These were out of CD player. They're on a PCB. They've got their own wires coming off. You can see which wires lead where with all the little things on the bottom. This is also a quadruple two-way switch, but it's got a tick 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 mechanism in it, like a toggle switch instead of a push button. Inductor. I'm pretty sure I took this off of something because it was in the way. I was trying to remove a different component, and this was in the way, so I had to take it off in order to get to it. I'm not gonna use this. Another motor. This one's got a gearbox on it. Ow. And all of my relays are in here. So my Takamisawa one, 24 volt to activate. And the Hankook Relay Co. one is in here, and well, all my relays are in here. All of them. All of them. And yeah, And I've got some transformers in here. Like this one here. And this one here that doesn't work. Don't know why I took it. I'm gonna make another power supply out of this soon. I'm gonna make one with this. Got a freaking alarm went off. But yeah, I'm gonna make a power supply with this one after I make a power supply with that red one. And apparently I've got a little piece of wire from this. Yeah, I like this type of wire. It's solid core. You bend it and it stays. Another motor. DC motor. This one's quite a powerful one. Quite a big one. It's got some in her. And a little switch. Press it, it's on. Let go of it and it's off, just like that. It's got its wires. I would put this into a small components box if it weren't for the wires. Another motor on a PCB. Exact same thing as the other ones. Where are they? This one's also used to be attached to a PCB. Where are those wires that motors! Frack. That I showed you earlier. Where the actual frick did those go? Weirdness. Oh well. But yeah. Same thing. Instead of a CD player, there used to be the second motor over here. No, this is not the second motor. This is out of a different thing. Frack. And I've got a vibration motor. I made a video about these on a different channel I used to have. And holy crap, I could not believe how many times I said vibrator. How many times I called these a vibrator motor. Holy crap, it made me cringe. But yeah, because I didn't know what a vibrator actually was back then. I thought vibrator just meant something that vibrates. But no, a vibrator is, you know, a girl's toy. Anyway, yeah. Got another vibration motor. This one's got a bigger weight on it, so it shakes more. I got these out of my PS3 controller. It stopped working. That's why I got this red one here. That other one I had stopped working, so I tore it apart, and I grabbed what I could out of it, including these motors. And the rechargeable battery. And some buttons. Capacitor. Anything else in here I haven't showed you yet? That was an interesting switch. I don't exactly like this switch. It doesn't have the thing coming out of it. You gotta stick your nail in there and move it. It's annoying. That was the voltage switcher of a computer. What have I not showed you? Oh, some potentiometers. Vibration mode. What the frick? There's a little tiny rectifier diode in here. What's that doing in there? A little tiny one. That's going in here. There we go. Ah. Oh, and an interesting capacitor. It's weirdly shaped. This one is 400 volts. That's powerful, huh? It's a 400 volt, but it's only 68 microfarads. Why did it have to be 68? It could have been one more, and it could have been so much better. Why couldn't it have been just 69 microfarads? This is another polarity switch that I made out of one of those nail-powered ones. You use your fingernail to move it. This one does not work so well. This one here works a lot better. First of all, because it's got the thing that you can switch it with your fingers. And it just... This one was made by a company for a device. And this one was made using twisting wires together and hot glue. And it did not come out well. Keeps shorting out. And that's the big components box. I just start overly aggressively throwing everything back in. Yeet! Yeah, I wouldn't do that. Half of my components would be destroyed if I threw these in there like that. Shove these out of the way. There we go. Oh, that's why that diode was in there. It was on the top thing for the rectifier for that power supply I'm making. But okay, but alright. Oh well. I'll carry this back into my room. Alright. Excuse me. Now I've got the box of power supplies. I had to plug my tablet in. It's starting to die. Move! There we go. Rack. So, this is an adapter, 9 volts, 350 milliamps, DC. This used to be for a phone. I think one of these phone ones, may have been for that phone I took apart. These were most likely part of that. Hold on a sec. I've decided I could unplug my tablet for a bit. It's okay. And my shoes are freaking wear. Alright, let's go outside and look at that phone thing. And it's real freaking warm for just a few days before Christmas. It's barely gone below -10 so far. Celsius. Quit complaining that I'm using Celsius, for frick's sake. I'm in Nova Scotia. I'm not in America, for frick's sake. You can't be mad at me for not using Fahrenheit, you Americans. Alright, we're at where I keep my electronic stuff. Well, my PCBs, mainly. Yes, I keep my circuit boards outside. Probably wasn't exactly the best idea, but oh well. They won't get destroyed. I'm never gonna well, they are destroyed, but the components will be okay. Water doesn't exactly damage, resistors and stuff, so. It may make them a little rusty, but I couldn't care less about that. What was I looking for? Oh yes, the phone. It's filled with snow. Alright, here's that phone thing. The top cover of it. 9 volts DC, yep. I'm guessing that Toshiba one was for that. Let's see what brand made this. Was it Toshiba? I don't see a brand name on it. Yeah, that's where I keep all my circuit boards and electronic debris. And the components I like, I take them off and I put them in, and I put them inside. Hey, Sparkles, what's up, baby? Psst, psst, psst. Come on, come here, baby. Psst, psst, psst. Why? She seems pretty scared of me. What's going on? Psst, psst, psst. Come on. There's something not right about you. What's going on? Something's a little off with Sparks. Not sure what it is. She seems pretty scared of me. She's running away from me, walking up to me right slow. Weird. She's not usually like that. She's usually the loveliest thing ever. I'm guessing that adapter fits into the old circuit board of that. I'm pretty sure I still have the circuit board for that phone in here. Maybe not. Frick! Stay up. Christmas tree. Christmas tree. Anyway, yeah. 9 volts DC, 350 milliamps. Made by Toshiba. I wonder what would happen to things if you plugged AC into DC devices. Like I plugged an AC adapter into that phone. I wonder what would happen if that phone worked and everything. What's going on here? Stay together, for frick's sake. You piece of crap. Frick off. There we go. Jeez. Battery am I at? 10%. My video ends when it hits 5%. Luckily, this is an Android, so it doesn't randomly shut off for absolutely no reason at 15%. I'm looking at you, iPhone. I'm looking at you. And my newest power supply, my 12-volt one. This one's not 100% complete yet, because I still need to solder and glue the wires onto those. The 120-volt wires are still bare. It's probably not the safest thing to be using this one. But yeah. Yeah, off AC and DC. 12 volts, 100 milliamps. Ningbo Deschwang Electronics Co. Ningbo Deschwang. Interesting. Definitely sounds some sort of Asian, that name. Probably Chinese. And this is a little rectifier board that's got a whole bunch of useful crap on it. Rectifier system, AC output, DC output, different types of input plugs, on-off switch, flash button. And soon it's gonna have a plug right here. That's like 2 screws. You can put a bare wire into it, and you screw it, and it grabs it. So you can hook it up to bare wired power supplies, like this. So I don't have to put plugs on them. And it's soon gonna have that polarity switch hooked up right here on top of the black rectangle, on top of the diode bridge right there. It's gonna be that polarity switch. This is a newer power supply. Well, the power supply itself isn't new, obviously. None of these are. But this one is my most recent one that I found. I just found this a couple days ago. This is the only plug I've ever seen in my entire life that doesn't have little holes in it. This one, 9.6 volts, 250 milliamps, DC. It's got a weird little plug at the end. I'm guessing it was some sort of charger for something. Frick. This little power supply, I keep forgetting that I have it. It's like the forgotten one. But I do have it. And it's a low power one. This used to power an LED lamp. Not an LED like light bulb, but a lamp that hooked onto the side of a table. This one is 700 milliamps, DC 9 volts. That's way more than I remembered. Huh. Cool. LED driver. Wait a minute, that's got a screw in it. LED driver. Maybe that's what I should be calling my LED powerer. I should call it a driver. Ooh. Smells burnt-ish in there. It's like burnt electronic. Oh, there we go. Whoa, we've got some complicated system in here. And out comes our power supply. Here it is. It's coolness. Alright, let's look around on this thing. 10 microfarads, 50 volts. That seems to be a fuse. It's cool. Diode bridge. A big diode. 330 ohm resistor. A transformer. A big capacitor. I can't see the microfarads. What about that capacitor? 4.7 microfarads, 400 volts. That's cool. It's got quite a system in there. Oh, I see why it's got quite a system in there. 120 or 100 to 240 volts. It's multiple voltaged. It's meant to be used in different countries. Because different countries use different amounts of volts in their outlets. I know some countries have 100 volts, some of them have 120, like here. Well, we've got 240, but split phase. And some of them, like Europe, use only 240. So that's why it's got such a system in there. It's meant to change the voltage depending on whatever the frick you give it. It's cool. Anyway, it's got its built-in switch, built-in rectifier. So, yeah, and leads out to bare wires. This is Zires. What's that one lead to? Oh, that's for the plasma ball. Plasma ball has, oh, remember the plasma balls? It's got its problem with it, where it sometimes doesn't want to turn on after a while. You'll touch it and it'll shut off. Well, I found out that's not the plasma ball doing that. That's this. This thing's freaking up. This thing has some very faulty short circuit protection inside of it. It's crappy, very crappy, and it often thinks it's being short-circuited when it's not, and it cuts the power for a second. So when you plug it into the plasma ball for a sec, the plasma ball draws quite a bit of power from it, and it randomly assumes for absolutely no reason that it's being short-circuited, and it shuts off. And it tries again, and it shuts off. And it tries again, and it shuts off. And it tries again, and it shuts off. It's stupid. It has a very unnecessary short-circuit protection in it. That's absolute crap. And what adapter needs a frickin' grounding prong? It's a transformer and a rectifier. Why does it need a ground prong? Stupid. And yeah, this one, however, has got a big system in it as well, obviously, for that crappy short protection. And because, just like this little one, it's multiple voltage input as well. As you can see, it looks almost as if you could take that plug off and put a different plug for a different country on. And, well, yeah, you could. Plug this little one in here. On. These eyes are starting to rust a little bit. Whoa, I just slid off of the bed. LEDs. Easy. Frack, this is really being a piece of crap. Yeah, I'm reburying these. Alright, wiring tool. Much nicer. Yeah, the water pump in the basement, it's got a little bit of a sensor problem, and it often thinks it needs to go when it doesn't. So that's why you hear every 10 minutes, well, not 10 minutes, definitely less than that. But that's why you hear every little bit, it's... And it needs oil. That's why it's so freaking loud and squealy. It never used to be that loud and squealy. It needs some oil. That's a very recent thing. Yes, it plugs into there very nicely now. That's... stupidly dim. Huh. Guess this thing ain't enough power. Power dose. Interesting. Oh, and I did some soldering there. Because the wire broke off. Got chewed off by critters, most likely. You know what I mean by critters, right? Mice, rats. They're infested through the house, and they've chewed up a lot of crap. A lot of wires for stuff. You love electronics, but there's mice in the house. It's a piece of crap when you find one of your devices with the wires chewed off. And this one looks quite similar to my plasma ball one. That's cool. Oh, and it's also got a special multi-voltage system in it. That's probably why. 5 volts, 3 amps. Huh. Huh. So it's a little bit like a high-power USB. 3 amps USB. That's a little much. I wouldn't charge a phone with that. It's a little too much current. But that is cool, though. Oh, I remember what this was for. This used to be for my alarm clock. This next one feels real light, so I'm guessing it has multiple inputs. Oh, no. 120 volts only. It's really light for its size. Output 26 volts DC, 210 milliamps. 26 volts, wow. That's a high power one. Not really a high current, but a high voltage. My highest current. Man, this little one here, this 3 amp one, is my highest current adapter. It's got the most amps of all of them. 3 amps. And my AC 9 volts 780 milliamp adapter. You guys seen this before. About to plug her into the rectifier thingy. And my baby monitor one. The one that goes bzzz. It's a lot quieter than I remember. Hold on. None. And yeah. Nine volts DC, 200 milliamps. That was a weird noise. It's interesting how this used to power a baby monitor for me, and now I'm using it as my own thing. This little one is 6 volts, 300 milliamps. 6 volts, 300 milliamps. Hold on. Get out of there. Here we go. 6 volts, 300 milliamps. These are exactly the same. Well, they're different. They're different, but they've got the same voltage and the same amps. That's my dad's flashlight charger. He charges his really bright flashlights with that. These ones. The 500 lumens ones. So this could charge them as well. This one doesn't work. I attempted to take that apart, but I could not get it apart. Don't know why. And the really heavy musical one. The Hitachi one. DC 9 volts, 500 milliamps. The one with screws in it. You can take it apart. Check out the insides. Get out of the way! There we go. Oh, and this little battery 2 wires thingy here that my friend gave me. And my homemade 6-volt one. And I found out I was wrong about the voltage. Again! I said it was 10 volts. Then I said it was 6 volts. Now I know for sure that it's 8. It's 8 volts. Oh, what's wrong with my nose today, man? I know I don't have a cold. Oh, and since you last saw it, I gave it a new modification. This big switch here turns on and off the capacitor. So, you can switch it to DC mode. And, however, you could choose whether it's actually smooth DC, like fully rectified, or if it's just, like, going like this. And you can choose whether it's smooth or jumpy. It's got that real big rocker switch. Yes, that's what that kind of switch is called. These ones that rock back and forth instead of go up and down. It's called rocker switches. Like the switches on them power bars back there. Like that one I showed you, but that had the little neon bulb in it. That's a rocker switch as well. These are not rocker switches. Yeah, this is my 9-volt power supply. I don't have any new news about this one. Oh, look at that. And in here also, it's a little lithium polymer battery, just like the one I've got in my components box. Except it's got a plug. And the very last adapter. Very last thing in this box. It's this one. 9 volts AC, 200 milliamps. Now, this wire is tangled all to crap. Well, not really tangled, but not wrapped around it anywhere. So I'm going to do that now. As you can see, this adapter is real small, and it's quite curvy. It's newer. It's quite a new one. Nearly all of my adapters here are out of old crap. That 6-volt, or that 8-volt one there, I got out of a, cassette player, and the 9-volt one there I got out of the same boombox that I got those 2 speakers out of. Yeah, and the transformer for my 12-volt power supply has a transformer out of a heater in it. This heater had a transformer in it that powered relays to turn on different things through the heater. Now I remembered why this is such a piece of crap to put away. It's curvy. It's not like a box like all of my other power supplies here. It's curvy, so it's real hard to wrap the wire around it and have it stay wrapped around. It's so annoying. So freaking annoying. Now freaking stay. There we go. Get out of there. There we go. Excuse me. Frick. Okay. Frick off, wires. Get down there, for frick sake. Whatever, good freaking enough. Oh, crap, I forgot to pause the video. I'm sorry about that. Anyway, I've got a couple of more stuff here. This is the last stuff that I will show you in this video. The last stuff, the very last things. This is my an LED power, just like my little one over there. But it's USB powered. You plug it into a USB port. And it's only got 2 LED slots instead of 12. And it does not have a 2-volt mode. But yeah, on, off, and the thing that turns off the capacitor. Plug that in. Bang! The charger's so hot. This is charging my tablet. This is the battery out of the PS3 controller. This is 3.7 volts. Maximum charge voltage 4.2 volts. Oh, I see. Yeah, 3.7 volt lithium ion battery. Pretty cool. Probably gonna stick that into the power supplies box. Right here, I've got plug wires. These are wires that have plugs on the ends. So I've got 3.5mm jack and some I'm pretty sure they're called flag connections. And some normal plug connections very similar to this. And some sound connectors. RCA sound. And yeah. And right here is wires. I'm not sure why I have some batteries in here. Or this little motor. With a gearbox. But yeah, and here's wires. This is a whole freaking whack of wires. And a big chunk of metal that I took out of a capacitor. Not tall enough. Alright, there we go. Now, let's clean this freaking place up. These LEDs into a small components box. Throw these away. I'm going to put this little motor into the big components box and this battery into the power supplies. Oh, and this USB LED power and the normal LED power all into the power supplies section. And now, the batteries. This light, wire and plugs, that include with the wires, charger cord, and this plasma ball. I'm going to put them back on my bed. Wiring tool, screwdriver, batteries, light. And put these all back into my room as well. These the lastings, the components box, and the wires bin. And the Nerf dart in the phone holder. Frick! Ouch, my voice. Why is this so freaking dirty? Goodness.